In this blog series, What NAEP Can Do for You, we take a look at the utility of using NAEP results and resources to improve pedagogy, assessment, and outcomes in the classroom. In these first two short videos, we explore how NAEP's long-term trend results in reading and mathematics reflect important national initiatives designed to improve student outcomes in the classroom. The NAEP long-term trend study in math is shown in this slide. Here we see the 9-year-olds begin the study in 1973 with an average score of 219, and the 13-year-olds begin with an average score of 266. In general, you'll see we see more movement in the mathematics trends than we saw in the reading trends. Let's take a look at how these scores align to the NAEP long-term trend performance levels. The NAEP long-term trend performance levels in mathematics cut across all the age groups surveyed in mathematics, indicating the longitudinal nature of the NAEP scale. The NAEP scale ranges from 0 to 500. The lowest performance level is 150. These are considered empirical performance levels as they denote what students at these levels can do based on the items the students answered correctly and the difficulty level of the items. You'll see that the 9-year-old trends range from 219, which is the lowest score in the trend line, to 244 here at the apex in 2012. The 13-year-old trend scores range from 264 at the lowest point in 1978 all the way to the highest score of 285 in 2012. So when we look at the empirical levels, the 9-year-old trend scores are in this level 200, beginning skills and understanding in math, where students at this level have considerable understanding of two-digit numbers, they can add them, but are still developing the ability to regroup and subtraction. The 13-year-old trends are within level 250, numerical operations and beginning problem solving. And students at this level have an initial understanding of the 4 basic operations. They can apply whole number addition and subtraction skills to one-step word problems in money situations, and they can find the product of a 2-digit and a 1-digit number. We see some uptick in scores starting in the 1990s, and what happened there? Changes in classroom instruction are captured in the NAEP questionnaires that gather student, teacher, and school perspectives related to the subject area tested. So in this case, something that happened in the 90s was the federal government started requiring through Goals 2000, asking schools to conduct daily math instruction. And one of the questions in the surveys asks educators if they conducted daily math instruction. And in 1978, only 75% of educators reported daily math instruction, while in 1990, 93% reported daily math instruction. This may have partially caused the increase in results from the 80s to the early 90s. Average math scores in the U.S. among 9-year-olds continued tracking upward in light of the 1989 release of the National Council of Teachers of Mathematics Standards document, reflecting world-class math expectations and mathematical classroom pedagogies, modeled after high-performing countries such as Japan and Singapore. These world-class expectations were operationalized in new mathematics programs that emphasized learning math through problem solving and learning more advanced mathematical topics such as fractions and geometry topics at earlier grades. Such programs included Everyday Math and Saxon Math. This also coincided with the introduction of the TIM study, the Trends in Mathematics and Science study as it's known now, which was first administered in 1995. In this graph, we look at the TIMSS average math scores in grade 8 starting in 1999 all the way to the last administration until 2023. And this graph looks at 9 countries. The US is prominently displayed in black, and there's a large comparison here to Japan's average scores, which is shown in green. The TIMSS study shed more light on international math achievement and classroom practices. TIMSS produced average scale score comparisons by country. They also conducted a groundbreaking series of classroom studies in 1995 and 1999, comparing representative classroom lessons across the countries. Some of the really interesting lesson comparisons took place between grade 8 math lessons in Japan in green and the US lessons in black, demonstrating the curriculum in Japan taught mathematics through active engagement in problem solving. As a result of the NCTM Principles and Practices Standards publication and the TIMSS study, there was a large impact on U.S. curricula, and both in terms of the content of the math instruction and the processes in math instruction. This likely had an impact on U.S. long-term trend scores, which we're looking at in this video. You can see that internationally, the U.S. student score averages increased until 2015, then with a slight decrease in 2019, and then a catastrophic decrease after the COVID pandemic, which we'll discuss. And we can see a surprisingly resilient trend in Japan and in Singapore, which tends to be one of the very highest performing countries. So once again, the trends are really helpful in understanding student academic proficiency in the U.S. and in other countries, and what could be done to change some of the worrisome trajectories. Significant average score increases were registered in the early 2000s with the No Child Left Behind legislation, which increased school accountability, but also school funding for public schools, as the legislation infused more than $45 billion in Title I funding from 2000 to 2007. The No Child Left Behind legislation also included a testing and reporting component requiring schools and districts to disaggregate results to evaluate the effect of the Title I funding on all student groups. Schools were also required to demonstrate annual yearly progress for all of these disaggregated student groups and for students across the board, meaning schools and districts infused a lot of time and attention and the resources to try to improve the outcomes in reading and mathematics to demonstrate annual yearly progress. So we see a large statistically significant increase from 1999 to 2004 for the 9-year-old. The increase isn't as large for the 13-year-olds, but it is statistically significant increase. Now we see another set of score increases around 2008 in math all the way to 2012. Two things occurred at this time. The first I'm going to talk about is Race to the Top, which was an Obama-era initiative that infused more cash into public schools. Race to the Top asked schools and districts to align their curriculum and their assessments to a new set of rigorous standards, a national set of standards called the Common Core State Standards Initiative. And the Common Core State Standards Initiative includes standards in reading and math. They were considered much more rigorous standards than the prior standards that most states were using, and the Common Core State Standards were designed to be used across the states. So the Race to the Top funding tied money to state projects that aligned their standards to the new, more rigorous Common Core state standards. And this probably had a very beneficial impact, particularly for the 13-year-olds. Race to the Top prioritized states' use of Common Core state standards by tying new grant programs and the development of new multi-state testing collaboratives. Two were featured, called Smarter Balanced and PARC, and Smarter Balanced is still very much used by a lot of states. But most state standards still heavily represent this Common Core State Standards Initiative, and most state testing programs still heavily borrow from this set of standards. Now we see a decrease in the 9-year-old and the 13-year-old average math trend scores from 2012 to 2020. In both of these age levels, the decrease is statistically significant. Researchers theorize these declines are attributed to increased screen time use for both age groups, but particularly, and with the sharper drop, the 13-year-old age group. Twench and Campbell in 2018 found a number of negative academic outcomes associated with spending an hour or more on screens. Middle and high school students were found to be using screens at a much higher rate than younger students. NAEP reporting is essential for keeping track of these worrisome trends. Finally, the COVID pandemic brought in-person schooling to a halt in many parts of the U.S. The level of disruption in schooling was significant, such that face-to-face schooling pretty much came to a halt in the spring of 2020, and remote schooling was the norm for most of 2021 in public schools. And this academic disruption caused an unprecedented drop in reading and mathematics, as you see here, where the 13-year-old students fell from their apex score in 2012 of 285 all the way down to 271, losing most of their gains and ending up almost 5 points on average where they started in the beginning of the study in 1973. And the 9-year-olds lost 7 points. So the 9-year-olds, as of 2022, were able to retain most of the gains that they had made, but still lost significant ground. By capturing these long-term trend results, NAEP does indeed live up to its reputation as the nation's report card.